Hi everyone, today we are going to work on exponential parent function. Our essential question is how can exponential functions be translated and represented in different ways? First of all, let's see what is an exponential function. If your function has an exponential term and the x is in the exponent, then we have an exponential function. The parent function looks like this, y equal to b to the power of x. So as you see, we have an exponential term here. The base is a number like b, and the exponent is our variable. X is in the exponent. So that's why we call this exponential function. If this b value is a number which is greater than 1, then we say we have growth in our function. That means as x is increasing, your y is also increasing. It's growing and going up. But if the b value is a number which is between 0 and 1, then we have decay here. That means our function is decreasing. As x is increasing, the y is decreasing and going down. Every exponential parent function contains the points 0 and 1 and 1 and b. Let's see why do we have these 2 points on our function. So this is x and this is y. We know that the parent function is y equal to b to the power of x. If x is equal to 0, I'm going to replace that here. This will be b to the power of 0. And we know anything to the power of 0 is 1. So that's why we have this point in our function. The other one, x is 1 here. So the function will be y equal to b to the power of x, which is b to the power of 1. And we know anything to the power of 1 is always equal to the base. B to the power 1 is base. So no matter what is my base, I always have 1 and b in our function. Like if the function is y equal to 2 to the power of x, we have 1 and b. If it's y equal to 3 to the power of x, we have 1 and 3. Also 0 and 1 is always in our function. So these are the 2 main points of our function. Also, every exponential parent function always has a horizontal asymptote at y equal to 0. We're going to talk more about this later. Now let's work on transformations. Any exponential function can be transformed, and the general form is going to be like this: a times b to the power of x minus h plus k. So we know that the parent function is a b to the power of x. If you multiply the function by a number like a outside of the function, then you're going to have vertical stretch or shrink. That depends on the value of a. If this a value is a number between 0 and 1, then you will have vertical shrink. If the a value is a number which is greater than 1, then you will have vertical stretch. Also, if you have a negative behind your a value, if basically this number is negative, that means we have a reflection over x-axis. Sometimes you add or subtract a number to your x value. That means you are moving your function to the right or left. If the h value is a negative number, you move your function to the right. If h is a positive number, so you move to the left. You can also add a number to your function. Outside of the function, you add something, not inside into x, outside. That is going to move your function up and down. If k value is negative, you move down. If it's positive, you move up. So let's work on this example now. Complete the table below for the function f of x equal to 2 to the power of x. Plot the points from the table on the graph, and then state the domain average. Okay, so this is f of x equal to 2 to the power of x. And we want to find f of x for different x values that are listed here. If x is equal to -2, then the function is going to be 2 to the power of -2. What is 2 to the power of -2? You can use your calculator or just evaluate that by yourself. So 2 to the power of -2, I can get rid of the negative by flipping the base and making the power positive here. So this will be 1/4 and is equal to 0.25. So the f of x or the y value will be 0.25. If x equal to -1, we have 2 to the power of -1. So this will be 1/2 to the power of 1, 1/2, and is 0.5. So this is 0.5. Then we have 2 to the power of 0 if x is equal to 0. And we know anything to the power of 0 is equal to 1. Then x equal to 1, 2 to the power of 1 is just simply 2. 2 to the power of 2, 4. 2 to the power of 3 is 8. So now I can plot the points here and graph my function. When x is -2, y is 0.25, somewhere like here. X is -1, y is 0.5. X is 0, y is 1, x is 1, y is 2, x is 2, y is 4, and x is 3, y is 8. So as you see, the graph is increasing, is going up. So we say we have a growth here. Function is going up. Okay, and the graph is going to look like this. Something like this. As you see on the right side of the graph is going up forever. It's continuing to grow. On the left side, what is happening? Let's see. On the left side, the x is going to get smaller and smaller. So the x will be getting closer to -infinity. So the function will be 2 to the power of -infinity. I'm talking about the left side as the x is getting smaller and smaller. So I get rid of the negative power in this way, 1/2 to the power of infinity. So this is going to be a really big number because 2 to the power of infinity is a really big number, and 1 divided by a really big number. So if you divide something by a very, very big number, it's going to be a very, very small number, but it's not equal to 0. It's just going to be a very small number. So that means on this side, your graph is never going to get equal to 0. It's just going to get closer to 0. It's getting smaller and smaller, but never passes. So approaches to y equal to 0. So that's why I can say that we have a horizontal asymptote here. So the function is approaching this line, which is y equal to 0, and that is our asymptote, y equal to 0. Next, we want to find the domain and range. Domain is about the x value, so we need to move from left to the right. So as I'm moving from left to the right, I see that there is an arrow here and also another arrow on the right side. That means the function is continuing from left to the right. It's going to cover all the x values, so it's just all real numbers. The range is about the y values, so you move bottom to top. As you move from bottom to top, you see that for the negative y values that we have here, there is no part of the function defined. So we don't see any part of the function here. The function is going to start from this point, which is right after 0. And the 0 itself is not part of my graph because we have an asymptote. Okay, so the function is going to start from 0, and I put a parenthesis here because the 0 itself is not included, and I have an asymptote here. Then, as I continue moving up, I will see that the function is increasing, going up forever, and we have an arrow here. So it's going to go to infinity. This is the range of the function. Now let's go to the next part of the lesson. In this part, we want to graph and fill out the information about these two functions. Let's work on this one first. The first one is y equal to 2 to the power of x minus 1. We know that the parent function for this function is y equal to 2 to the power of x. So you just simply take the base, which is 2, and raise to the power of x. This is the parent function. And we learned that any parent function contains two specific points. One of them is 0 and 1. The other one is 1 and the base, which is 2 here. So these two are on our parent function. I'm going to graph them here, 0 and 1, plot them here, and 1 and base. The base here is 2. So I'm going to write that as 1 and 2. So the points is 0 and 1 and 1 and 2. This is going to make our parent function. I'm going to draw it with dotted line to say that this is not my original, it's just my parent function for now. So this is the parent function. Now, let's graph the original function, 2 to the power of x minus 1. What transformations do we see here? As we see, x is subtracted by 4. That means we are moving our function right 4. So any point that we have on the parent function needs to be moved right 4. So I'm going to move this from here right for 1, 2, 3, 4. And the other point that we had here, this is also going to be moved right for 1, 2, 3, and 4 here. So these are my new points. And also, we learned before that we have an asymptote here, a horizontal asymptote here. So as I move my function to the right, the asymptote is going to be the same because this is just a long line that is continuing from left and right. If I move it to the right, nothing is going to change. I'm still going to have the same line. So the asymptote is the same. So I can graph my function now. It's going to be like this on this side, and on the other side it's getting close to the asymptote and continues the same way. So this is my graph now. Is it growing or decay? It's growth, because the base value is a number which is greater than 1. That's the base. Now, what is the domain? For domain, we move left to the right, and as you see, everything is defined here. We have an arrow on the left and the right side, so it's just all real numbers. The range, you move bottom to top. Again, we have the same thing because the negative values are not defined, and the function is starting from right after 0. So it's from 0 to infinity. It's continuing on the top side. So that's the range. Now let's work on the other function here. We have y equal to 1 over 2 to the power of x. So as you see, this function is basically the parent function because it's just y equal to a base to the power of something. This time the base is 1 over 2. Instead of, for example, 2, we have 1 over 2. So this is still my parent function. So the base here is 1 over 2. And because it's a number which is between 0 and 1, so we don't have growth here. We have decay here. Okay, now I can graph my function. There is no transformation here because this is parent function. Now, to graph my function, I need points. The two main points are 0 and 1, and 1 and the base, which is 1 over 2. So I can graph it 0 and 1, and 1 and base, which is 1 and 1/2. And we know that any parent exponential function always has the asymptote at y equal to 0. This is still my asymptote. And the graph is going to be decreasing So it's something like this. On the right side gets close to the asymptote, and on the left side goes up. So as you see, it's decreasing. It's going down from left to the right side. As I check my function, it's going down. Now, what is the domain? Again, I move from left to right, and I see that there is an arrow here and another one here. So the function is covering all real numbers. For the range, you move bottom to top. Again, we have the same thing because your function is starting from right after 0. So 0 and infinity. And we put parentheses because 0 itself is not included. We have an asymptote at y equal to 0. Okay, now let's work on the next example. On this example, again, we want to graph and fill out the missing information. The function is negative 1 over 2 to the power of x plus 5. So what is our parent function? Just take the base, which is 1 over 2, and the x. This is our parent function. So what is our base? It's 1 over 2. What transformations do we see here? We have a negative here. That means reflection over x-axis. Also, we have added 5 to our function. That means we are moving our function up 5. So these are the transformations. Now let's see what is happening here. Graph of 1 over 2 to the power of x. The parent function has these 2 points, 0 and 1, and 1 and 1 over 2. It's the same thing that we just graphed here. So this is our parent function. I'm going to graph it first here. 0 and 1, 1 and 1/2. I graph it with dotted line because this is not the function that I want to graph. It's just the parent function. Okay, so this is parent function. Now, what transformations do we see here? Up 5. For the parent function, the asymptote was here at y equal to 0. This was our asymptote. Now that I'm moving my function up 5, that means everything is moving up. Also, the asymptote is going to move up. So the asymptote was at 0. Now it's going to be moved up 5. 1, 2, 3, 4, 5. So here is my new asymptote. And these 2 points also are going to be moved up. 1, 2, 3, 4, 5. So one of the points is here. And this one, again, moved up 5 is going to be here. So this is my function when I move it up 5. But I have not done reflection over x-axis yet. So it's not my final graph. Now I need to flip this and apply the reflection over x-axis. So to flip it, I just move this point down here. So to flip it over the asymptote that you have, it's going to be, and also the other one, you just flip it. So the same amount that you had on top of this line, you're going to go the same amount down here. So this is my new point. Now, because this is flipped, the graph is going to look like this. This will be the graph of my. Okay, so this is the graph, and as you see, because the base was 1 over 2, it was supposed to be a decay here. But since we have reflected this over x-axis, now this time our function is going to increase. So this time, because we have a negative, it's going to be a growth here. Now, what is the domain? You move from left to the right. We have an arrow here and another one here. So it's covering all real numbers. For the range, you move bottom to top, and this time you see as you're moving bottom to top, the first thing that you see is this arrow. So this function is continuing going to the negative infinity from the bottom side. So starts from negative infinity, and where does it end at? It ends at here almost, because we say the graph is getting closer to this asymptote. Y equal to 5 is our new asymptote. Your graph is getting close but doesn't pass, just approaches this line. So 5 is the last point, but because the 5 itself is not included, we put a parenthesis here. Okay, so for the next example, we have y equal to negative 1 over 2 to the power of x minus 2 plus 1. Again, what is my parent function? Y equal to 1 over 2 to the power of x. This is my parent function. Just take the base and the power of x. So the base here is 1 over 2. So we expect that we have a decay here. Let's see what is going to happen later. So what transformations do we see? First of all, we see a negative here. That means reflection over x-axis. Then we have x minus 2. We are subtracting a number from x. So that means the function is going to move right 2. And we are adding 1 to our function. So we add 1, it will be moved up 1. So these are the 3 transformations that are happening to our function. So let's see. The parent function, as we graphed before, has these 2 points, 0 and 1, and 1 and 1 over 2. So 0, 1, 1, 1 over 2. This is my parent function. Okay, this is our parent function. Now, we move this right 2. So as I move this right 2, these 2 points are going to be moved right 2. So at this point, it's going to be here, and this one will be here. This is the first thing that happens. Then the asymptote that we have for the parent function. This is the asymptote for the parent function. Because I'm moving the function to the right, the asymptote will be moved to the right, but because this is a long line that is going to continue to right side and the left side to negative and positive infinity, as I move it to the right, I'm not going to see any change basically, because this is just a long line. So moving right 2 doesn't change my asymptote. But if I move up 1, what happens? Then these 2 points are going to be moved up 1. Let's draw with another color. Up 1 here, and this one will be also up 1 somewhere like here. Then the asymptote also is going to be moved up. So this is the new asymptote now. So we did these 2. Now the last one is reflection over x-axis. So these 2 points need to be reflected over this asymptote basically. So I'm going to use another color. So this point, which was here, now it was 1 unit above the horizontal asymptote. Now it's going to be 1 unit below that. This is my new point. And this one was half a unit above. Now it's going to be half a unit down because it's reflected. So these are my new points. Now the graph is going to look like this. Getting close to the asymptote on the right side and then going this way and going to negative infinity on this side. So this is the graph of my function. As you see, because this is reflected over x-axis, now we have growth in our function. Now, what is the domain? Left to the right, you see an arrow here and another one here. So it's continuing to the left and right side. So it's just going to be all real numbers. All real numbers. Range, I move from bottom to top. From the bottom side, I see an arrow. That means it's going to continue to the negative infinity. And the top side is getting close to this asymptote, which is y equal to 1. This is our new asymptote. So it's getting close to this line, 1, but doesn't pass. So we have a parenthesis here. Okay, so this was today's lesson. I hope it was helpful for you. Have a great day.